Greetings to one and all. In this particular video, we are going to start with data science and big data analytics laboratory practicals. This is Group A Data Science assignment number 1, in which we are going to study about data wrangling techniques, part 1. So the first assignment is to perform the following operations using Python on any open source data set. We need to import all the required Python libraries. We need to locate a particular open source data set from the web, maybe from Kaggle. The data set will be loaded into a pandas data frame. Data pre-processing techniques will be applied in order to find the missing values in the data. Also, the data formatting and data normalization techniques will be exercised. Also, data type conversions and turning the categorical variables into quantitative and dummy variables in Python will be discussed. So these are the different activities that are conducted in the data science life cycle. Firstly, the business problem statement is detected, which will help us to provide the customized offers to the customers. Then the data collection is done, the data gathering, and then the data is pre-processed or it is prepared. That is, data wrangling has been done. So in this video, we are going to focus on this third step of data preparation. So pre-processing data in Python. The process of converting or mapping data from initial raw form into another format in order to prepare the data for further analysis is called as data pre-processing. We are going to process the data and prepare it so that we can carry out further analysis in the correct way on the data. This is also called as data cleaning or data wrangling. So in order to deal with the missing values in Python, first of all, we need to understand what is a missing value. Missing values occur when no data value is stored for the particular variable or feature in the observation. Means there is no particular value in that particular cell or field in the data frame. A data frame can be considered as a collection of rows and columns. So as you can see here, NaN has been displayed, means not a number, or you can say the value is not available over here for this particular cell. This is called as a missing value. This could be represented with a question mark or this symbol n/a or 0 or just a blank cell. If you open the CSV files, that is comma separated values files, if you open these files using the Microsoft Excel application software, that is this one, wherever there is a missing value, you will get to see a blank cell. For example, here in this particular row 13279, there is a missing value, so you cannot see any value over here. It's a blank cell. But when you load this data set, that is this comma separated files, values files, if you load it inside your pandas, it forms a data frame, and in that data frame you will get to see NaN, that is not a number, or you can say missing value. So how to deal with these missing values is, first of all, we need to check the data collection source. If there is some issue at the collection source, or we may change the data collection source, or once we collect the data, we find some missing values, we may either drop that variable or that row or that particular column, or we can drop that particular cell. Or if we don't want to drop that row, then we may either replace all the missing values with some other value. For example, if there is a particular missing value over here, then we need to replace it. Instead of dropping this whole row, we need to simply replace that missing value with some other value instead of dropping this whole row which contains a missing value. So we can replace that missing value or that blank cell with the average of particular data points. That means this cell can be filled with a particular value, which can be the average of this particular column. This may be a particular column which has multiple rows. So we can take the average of all these values, and whatever average we get, we can fill it in this missing value. We'll see this all through the actual practice in the practicals. That time it will be even more clear. Or we can replace it with the frequency. Now suppose this column contains all numeric values like 7 or 2.5. Then taking the average is possible because it is a column which has numerical data. So taking average is possible. But what if there is a string stored in each of these columns? For example, apple, banana, or such things are stored in each of the cells of this particular column. Instead of numbers, we have some strings, you can say. Then it is not possible to take average. In such cases, we take the frequency. That means if apple is appearing 5 times in this particular column, and then banana is appearing 4 times in this particular column. So based on which string is appearing maximum number of times, for in this case apple, that value apple will get stored in place of this missing value. Okay, we are taking the string which has the maximum occurrence in that particular column, and that's replacing the missing value with the most frequently occurring string in that particular column. Or we may replace it based on some other functions. Like if the values in the column are greater than 5, then fill the missing value with 6. Based on such user-defined functions also, the replacement of the missing value can be done. Another option is we may simply leave the missing value as it is. It depends on the application. We may either replace the missing value or drop the row or perform some pre-processing, or we may leave the missing values or the missing cells as it is. Another way is we can fill that with some other value. Maybe with this missing value that we have over here, this is a missing value, can be filled with this particular value. The value in this particular cell can be filled in place of the missing value. The value in this cell can be filled over here. Or maybe the value in this particular cell can be filled over here. Or the value in this particular cell can be filled here. Or maybe this particular value from this cell can be filled over here. Means either the previous value in the column or the next value in the column or the previous value in the row or the next value in the row can be filled in place of the missing value. This also we'll see when we go to the practical. So in order to drop the missing values, we use drop NA function. This is predefined, it is already available. We simply need to call it on the data frame. So as you can see here, we have NaN, that means missing value. Once we call this drop NA function, we'll be able to drop this particular row in this particular case. So this syntax that we use is, suppose df is the data frame, then we will say df dot drop NA, and access equal to 0 means we are considering in the row. For example, in this particular row, we are analyzing if there is a missing value or not. Row wise we are analyzing. But suppose access is equal to 1. If access is equal to 1, then it means in the column we are searching. Column wise, we are searching for the missing value in that particular column. So access is equal to 0 means in that particular row, row wise, and access is equal to 1 means that particular column, column wise. Now how to decide which row and which column? Suppose we say we want to find the missing values in the price column. Here there are two columns, highway and price. So in the price column, we are searching for the missing value. Or maybe more than one column also. We want to search for the missing value in highway column as well as price column. So to select the particular columns, we will write subset is equal to, in a list, Python list, we will give the names of these columns. For example, here in this particular list, we have mentioned price. as the name of the column. So only in the price column it will search for a particular missing value. And how it impacts if we write access is equal to 0. If we are saying access is equal to 0 means, first of all, it will consider only the column price. It will consider the column price. As soon as it gets a missing value, it will drop that entire row. Okay, the row will be dropped when we say access is equal to 0. Similarly, if highway is the column that we are interested and it finds a missing value here, then as soon as it gets the missing value here in the highway column, it will drop this particular row. So access is equal to 0 means the row we are considering, so that if we find a missing value in either of these columns, then that particular row in which the missing value is, that row will be dropped or removed from the data frame. I hope this is clear. Now, if we write another parameter in place equal to true means, in the original data frame which you have loaded, in that original data frame, the changes will be done. Suppose you don't write in place equal to true and you make this change, the row gets dropped, but this change will not be reflected in the original data frame. So you can say at that time, you can create another data frame variable like df1, and you can say df1 is equal to df dot drop na, and you can pass the parameters. Suppose you're not saying in place, then what will happen is, here we are not writing in place equal to true. Then whatever change is done to the df data frame, this is the df data frame, whatever change is done by dropping the required rows which have missing values, those changes will be not reflected in the original df data frame. So we are storing those changes, means we are storing the updated data frame, the updated data set we are storing inside another variable called df1. So now if we print df, that row will still appear, but which has been dropped actually. That row will still appear in df. But when we print df1, that particular updated data frame will get displayed. Okay, we'll see this in the practice. So remember that whenever you don't write in place equal to true, it means that, for example, this case, when you're not writing in place equal to true, it means that whatever changes are done on the data frame is not done on the original data frame. But when you write in place is equal to true, whatever changes are done on the data frame are done on the original data frame. So if you want to check out more about pandas, or if you want to know about the syntax, the different parameters, so here actually we are using keyword arguments. We are passing the keyword arguments to this particular method. Keyword arguments means we are specifying the name of that particular argument which lies in the function header. So this drop na function has been defined somewhere already for us. We have to simply call this method. It has already been defined. Whenever it has been defined by the developer or the programmer, whoever has developed this pandas library, there he has mentioned like subset or access. These parameters he has already defined, and these are the names of those parameters. Subset and access are the names of those parameters, and to these parameters we are passing the values when we are calling these methods. To the access parameter we are passing 0 when we are calling the drop na method. So this is called as keyword arguments. Okay, here the main advantage is the order of passing arguments is not mandatory, or it is immaterial, and by default the access is 0. So if we don't specify access, then it considers row wise only by default. But if we specify access is equal to 0 when we are calling this particular drop na method, that time if we are passing access is equal to 0, then the row is considered. If we pass access is equal to 1 while calling drop na, the column is considered. And if we don't pass access, we don't pass any value here, we skip this particular argument, then by default access is equal to 0, so the row wise is considered. Now in case we want to replace the missing value, we don't want to drop the row if it has a missing value. Instead, if that row has a missing value, we want to replace that empty cell or that missing value with some other value. Then what we will do is, we'll first of all pass the particular value which we want to replace. That means this here we may either pass the missing value, that is nan, or you can say nan, and we cannot pass this nan directly. We need to take help of the numpy library. This is another library like pandas that we have predefined. So we can write here np.nan, where np is an alias for numpy. So whenever we use pandas or numpy, we need to import these libraries in our program by writing import pandas as pd, import numpy as np. This pd and np are alias you can say for pandas and numpy respectively. So we write np.nan, and we want to replace this nan value with some new value, say suppose 5. So the first parameter is what? The value which you want to replace. And the second parameter is what? The value which needs to get replaced in place of this. Now, not necessarily always you want to replace a missing value. Suppose in your data frame you have the value 6, but due to your requirements, you want to replace the value 6 with 5 everywhere in your data frame. Then what will happen by this particular passing of parameters? This is the value 6 which needs to get replaced by the value 5, right? So wherever 6 appears in your data frame, it will simply get replaced with 5. This is the meaning of these two parameters. Usually we replace the missing values, but it may be a case where we want to replace the other values also. So I have shown you both the cases. So this is another example where we want to replace all the missing values in this particular column. You may want to replace in a particular column, okay? So you may consider this particular column, normalized losses. This is a data frame in which you have a column with the name normalized losses. Here, if you have NaN, then that NaN, that is np.nan, should be replaced with mean. Now, it is a possible case where we want to replace the missing values with the mean, median, or mode that we have studied in statistics. So what we will do, first of all, we will calculate the mean of all the values in this particular column. Okay, we'll calculate the mean of all the values which are present, like 164, 164, 158, and there are some other values also which are not shown here, like they are simply represented. It is understood that there are some more values here. So we'll take the mean of all these values, and that mean we will store in place of the missing value, because it makes more sense if we are storing the mean, median, or mode, because it shows that the particular value is in the particular range. For example, here if we have 164, 158, that means we can say that the values in this column are in the range 150 to 170, suppose. Okay, just an example. All the values in this column are in the range 150 to 170. Then the mean will also be within this range, which we are storing in place of this missing value. So if we store any random value, like a very high value or some very low value like 1 or 1000, then it creates a ambiguity, or you can say discrepancy. Okay, because if there are some values which are suddenly out of range, it creates an impact in the analysis that we do on the data. The values that are considered are usually considered that they are in the fixed particular range, because suddenly if you say you have scored 80 marks, then suddenly the next person is scoring 1000 marks. It is not possible, because the paper may be out of 100 marks only. So such values which are not valid, or you can say which are not matching with the other values in that column, such values will create a problem in your future analysis of the data. So we prefer to replace such missing values with the mean or such relatable values. I hope this is clear. For this we do different techniques are used. So how to find out the mean is, you have to first select that particular column of the data frame. How you'll do it? df of normalized losses. Like how we select a particular element from an array. Suppose A is an array, then A of 2, when we say, it is the element at index 2. within the array. Similarly, DF is considered, you can consider it as a matrix for simplicity because it consists of rows and columns, though it is not a matrix, but it is consisting of rows and columns. So we are selecting this particular column and we are finding the mean. How? By applying another predefined function built-in method called as mean. So this method, when it is called on the normalized losses column, it will find out the mean of all the values in this column, which will get stored in this mean variable. And this variable now holds the mean. So we are storing it, we are passing that variable, or we can say that particular mean value as the second parameter in this replace method. So first of all, we are going to replace all the null values or missing values with the mean in the column normalized losses. Okay, I hope this is clear. So after you do this, what will happen? The missing value will get replaced with the mean of this particular column. So this is how we can replace the values. Now how we can fill the particular missing values or the empty cells with some other value. This can be done using the fill any method. Okay, this is used to fill the particular missing values with some other value. So we have seen a few ways. That is, mainly we use the dropping technique, the replacing technique, and the filling technique. So we can either drop that particular row, or we can replace the empty values or the empty cells with some other value, or we can fill it with some other value. These are three ways which we will see in the programming examples. So in order to work on pandas library or some other library, or if you want an environment to work on this, you need either Anaconda Navigator, which comes along with different application softwares. Like you can have Jupyter Notebook, you can have PyCharm, you can have RStudio, VS Code, Spider. All these come as a complete bundle, as a package whenever you install Anaconda Navigator. And you can use any of these. Or if you want to use only Jupyter Notebook, which is very frequently and highly used for data science applications, data science related applications, then you can either go for only Jupyter Notebook. Or if you don't want to install any software like this, then you can go for Google Colab also. It is a cloud-based environment that is provided to you, wherein you can use the particular resources on remote servers for the particular time that you need, and then you can close the connection with that server. So if you are going for Anaconda Navigator, in order to download this particular environment, you can simply type Anaconda Navigator download in the search, and then you can click on this link. And then below you will get these links for Windows operating system, Mac, and Linux. You can go for 64-bit or 32-bit based on your system configuration. Or you can go for Jupyter Notebook. Click on this first link. It will open this. You can try it in your browser directly without installing, or you can install Jupyter Lab. When you try it in your browser, you can click on this option. It will take some time to load. And once it loads, you will get to see the environment. Like this. You can either select a new notebook for Python, and here you can start typing the code. You can run it and all those features are available. Or you can go for simply Google Colab, and you can create a new notebook or your previously used notebooks. it will provide you the same kind of interface, and you can load the different data sets by using this particular section. And here also you can type the program, you can connect. Okay, so once you open Jupyter Notebook, if you have installed Anaconda Navigator, first of all you need to open your command prompt. It's an easy way to open Jupyter Notebook from Anaconda Navigator. You can simply open Anaconda Navigator and click on launch, but it takes a little more time. So preferably what I do is you open your command prompt and simply type here Jupyter Notebook and click on enter. So within a few seconds, it will open Jupyter Notebook in your browser itself, like this one, like here, this will open first. So you can navigate to the required folder. You can go on desktop and search whatever you have. On desktop, I have this particular folder. Then I go inside here. In this, I have my required notebooks. The extension of these notebooks, Jupyter Notebooks, is known as IPYNB, IPython Notebook. So in whichever notebook you can click on that, or if you want to upload a notebook here, you don't want to browse through your system, then you can simply click on upload, and whichever notebook you want, you can simply upload it. It will appear here. Or you can also do one thing, that you can create a new notebook directly here by clicking on new Python 3. So for now, we are going to deal with this particular notebook, that is missing values, and see all the data processing techniques related to handling the missing values. So here, first of all, pandas library is required, which is widely used for data analysis and manipulation in Python for data science applications, machine learning, and so on. So in order to import this library inside your program working environment, you need to simply write import pandas as PD. As I mentioned, PD is an alias. It is a name given to pandas by which you will refer it in your program. If I don't write as PD here, that's also fine. But then whenever I call that particular library or package, I'll have to write pandas dot method name. So writing pandas every time is a bit tedious. So we write import pandas as PD. And now instead of writing pandas dot read CSV, I will write PD dot read CSV. So it reduces the effort over here. Similarly, NumPy is another library for numerical operations, numbers and all. We are importing it as NP. Okay, so whenever you import this Python libraries, you have to first you load the data frame inside your working environment, inside your program, inside a data frame. So that can be done by writing pd dot read underscore csv. Read underscore csv is another built-in method, and as a parameter you need to pass the csv file. Now as you can see, here I have that CSV file in the same directory or same folder. That is why I have to simply give the name of that folder with the extension CSV inside double quotes. Suppose your CSV file is in some other location, in some other drive, then accordingly you have to give the path of that particular location over here. Just giving the file name will not work if that particular file is not in the same directory where your notebook is. The notebook as well as the data set, the CSV file, are in the same directory. That is why specifying only the notebooks, specifying only the CSV file's name is sufficient over here. And if we want to access only the top 5 rows, then we can say df1, that is the data frame. We are referring to the data frame using df1 over here. So whenever we say df1.head, it means that the top 5 rows of that particular data set we want to access. You can open the data set in Excel and see it if you are interested. There are so many columns, okay, and so many rows as well. If you see the count of rows, it is 13,000 and odd. Okay, so there are so many rows, but I want only the top 5. That means 1, 2, 3, 4, 5. I want only these. So index starts from 0, you have the top 5. Suppose you want top 10, then simply pass 10 over here. And now when you run this, in order to run a particular cell, each thing is a cell in Jupyter Notebook. All the cells are interconnected. So when you click on this particular cell, you can either click on this run option or simply using your keyboard shortcuts, shift enter. Okay. So when I pass 10 here, 0 to 9 is the index, top 10 columns and top 10 rows are selected. Suppose I pass 5 as the parameter, then also top 5 rows are selected. If I don't pass 5 also, top 5 rows are selected. Means what? 5 is the default value of the parameter n. Usually we can also write n equal to 10 or n equal to 5, or simply we can pass 5 also. That is also fine. So top 5 rows. 5 is by default. If I simply write df1.head, top 5. If I write df1.head 5, then also top 5. If df1.head 10, then top 10. Okay. So usually we don't want to load the entire data frame in the display. We want only suppose top 5 rows, just to understand what exactly may be there in the data frame. Now, if you want to find out all the unique values in this particular column, area type, as you can see in this area type column, this bangalore.csv is actually a file which contains the house related data, means which houses are for sale and all such things. Usually this data set we use for house price prediction problem. So here we have an area type column. It suggests the area. So there are different values, but as you can see, this super built up area is being repeated more than once. Means what? This is a value which is not unique for this column. But if you want all the unique values, means this one, then plot area is another unique value. Means maybe it may be repeated further. Here there are only top 5 rows. In the data frame over here, it may be repeated number of times. But we want only the single occurrence. Means if there are multiple values, we want to know only the unique values. So unique values will be what? Super built up area, then plot area, then built up area, means the single occurrences we want. So that can be done by using this df1 area type. Just a minute. So here we have this df1 area type. We are selecting this particular column. Dot unique is a method which is called. So it will display all the unique values in this particular column, as you can see. Similarly, if you want to know about how many times each of these values has appeared in that particular column, like super built up area is appearing 8790 times in this particular column area type. So we are finding out the total occurrence of the particular values in that particular column. Similarly, we have plot area as another value that is observed in that particular column for 2025 times. Okay, so this will display the value counts. Now, if you want to find out if there are any null values or missing values in your particular data frame, as you can see, as I had mentioned, in your CSV file, if there is a missing value, you won't get to see anything over there. For example, here, here, and here. But in your data frame that you display here, you'll get to see NaN. That stands for missing value or not a number, missing data. So if you want to find out whether your data frame has missing values or not, you must simply call this isNull method. So it returns the data frame in the form of true and false Boolean values. So wherever there is a null value, it shows true over there. For example, in this second row, in the society column, you can see a second row society column, there is NaN, missing value. If there is a missing value, true. But as you can see here, this is not a missing value. So there it will be false. Okay, so wherever there's a missing value, it will show true in this particular method. Now, this may not be the ideal case. You just want to know for each column how many missing values are there. That time what you'll do is null, and on this you have to call the sum method. Okay, first of all, what I'm doing on my data frame, I'm applying the isNull method. What is the output? This particular true and false format. Now on this, I'm applying or calling the sum method. So if you see the output, for area type column, there are 0 missing values. For, as you can see, all are false. For this society column, there may be, this is one missing value, there's another one. In between the columns, the rows are not shown. You can see top 5 and bottom 5 are shown. In between, there are so many rows which are not shown. Okay, because you can see there are so many values showing everything is not an ideal case. So there are just some dots here which indicates there are rows in between. Okay, so fortunately there are no missing values in this area type column, but in the society column, maximum missing values, as you can see, 5502. So it will give you the count of missing values column wise. Now again, this, there may be another possibility that you want to find out the total number of missing values. That means what? You want to do 0 plus 0 plus 1 plus 16 plus 5502 plus 0 plus 73 plus 6110 or 610 plus 5. You want to add all these. That time what you'll do? df1.isNull.sum. And on this you will call again sum. So when you do this, it will return the addition of all these values. That is 6206. Okay, so this is how you can find out the missing values either in Boolean format or column wise or in total how many missing values. I hope this is clear. Now, if you want to fill all these missing values with the value 0, you can write it in this way. All the missing values will get filled with the value 0. And whatever these changes are done, I'm going to store it in another data frame df2. Okay, means I'm creating another data frame in which there are no null values, because I'm going to replace all those null values of the data frame 1. From df1, I'm going to replace all the missing values with 0, and that updated data frame will get stored in df2, and I'm going to display df2. So as you can see here, there was a null value which has been replaced with 0. Suppose I want to replace that value with 200. See, now that value has been replaced with 200. The missing value has been replaced with 200. I may also want to replace it with a particular string. Now in pandas, it is not called string, but it is called as object. Your Python string is called as object. So if I run it now, instead of the missing values, I have apple. Okay, because that is the value which I have passed. But now, suppose you print your original data frame df1, then will you get this apple instead of the null value in df1? No, because as I said, in df1, that missing value only will be there, but those changes that have been done on df1 is getting stored in df2, and df2 is the updated data frame which I'm displaying. But df1, your original data frame, is the same. It has not gone. Those changes that I've done are not stored on the original data frame. But suppose I want to store these changes in the original data frame itself, then what I'll do? Yes, I will write in place equal to true. What happens by this? I've explained it in the presentation that whatever changes you do in data frame 1, they will get stored inside data frame 1. So now if I display df1, you can see that I'm displaying df1 where the change of apple in place of the null value has been reflected. Okay. So it may be a case where you don't want to alter your original data frame. That time in place equal to false. You can pass false also. Or simply don't pass this parameter. By default, it is false. Okay. Or you may want to make the changes on your original data frame. For that, we use in place parameter. Just a minute. Okay, so now we want to fill those null values with the previous value in the same column. Means what? Here you have a particular null value in the row with the index 2. You have a null value. This value we want to replace it with this particular value. Means this null value should get replaced with the previous value in the same society column, right? So for using such functionality, what we'll do is we are going to use the fill na method only to fill the null value with some other value, but pass a parameter method equal to pad. What this will do is this parameter causes your null value to get replaced with the previous value in the same column. So now when I execute this, I'm storing the change in df3 and displaying df3 as the data frame. Here there was a null value in this row 2 column society. You have seen that there was a null value which has got replaced with this previous value, right? I hope you can observe this change. Now what I want to do is this null value over here, I want to replace it with the next value in the same society column. Okay, now the next value, that time the method will be bfill. You're passing the parameter with the, you're passing a value to this method parameter. That value is bfill. You're passing bfill as a value to the method parameter. In the previous case, we have passed the value pad as the value to this method parameter so that it could replace the previous. But now we want to replace the null value with the next value. That time we pass method equal to bfill. Bfill stands for backward fill. And now if I display this data frame, you can see that the null value over here in the column, in the row with index 2, in the society column here, it has been replaced with this next value. This the next value has come in place of that null value. So we have seen to replace the null value with its previous and with the next in the same column. Now there may be a case that we want to replace the null value with this previous value in the same row, or we may want to replace this null value with the next value in the same row, right? So for this, what we'll do, we simply need to change the axis. As I had mentioned, axis is equal to 0 means it is the row, and axis is equal to 1 means it is the column that we consider. So by writing bfill, we are going to consider the next value. Bfill means the next value, and axis is equal to 1 means just a minute. Yes, so we want to fill it with the previous value in the same row. Okay, so we are going to fill it with this null value. We are going to fill with the next value in the same row, that is 1440. So as you can see, it is 1440, and suppose axis is equal to 0, it is considering the in the same column. Okay, so here there's a change actually. For axis is equal to 0, it is considering in this way, that is, this is the second row or row with index 2, and this is the third row, that is row with index 3. In these two rows, when we write axis equal to 0 means row wise. So either we can say that we are going to replace the null value with the next value in the same column, right? We are replacing the null value with the next value in the same column, society column, or we can say that when access is equal to 0, the next value in the column, or when access is equal to 0, we can say that the next value in the next row. That is how it means access is equal to 0 over here. This is the second row, third row. So in the second row, we have NaN. In this third row, we have this particular value, which will come in place of NaN. That is the meaning of access is equal to 0. Another way of saying it is that in the same column, the next value, or another way of saying it as in the next row, we are considering the value in the same column. Okay, it is happening in the same column, but we are taking the value from the next row. I hope this is clear. Similarly, when we say bfill, and by default access is equal to 0, so when access is equal to 0 and it is bfill, means we are taking the next value and from the next row in the same column. Okay, similarly, if the access is equal to 0 and it is pad, means what we are considering, we are considering the previous value in the same column from the previous row. This is the row which has the null value from the previous row, that is this particular row, in the same column we are taking. Okay, so that is the meaning of access is equal to 0. Now suppose access is equal to 1. This is the meaning that in the same row but from the previous column, same row and previous column. 1 stands for column. Okay, so we can say that in the same row but from the previous column, that is we have found the null value in society column, the previous column is size column. In the same row we have 3 BHK which will get replaced in place of this NaN. If there's an asterisk over here, means it is still running that particular cell. So as you can see here, in this second row in society column, NaN should get replaced with 3 BHK. Second row society column, NaN has got replaced with 3 BHK. Okay. Now similarly, if we want to fill it with the next value in the same row, means what? Instead of 3 BHK, we want to store 1440 inside NaN. That means we are considering the same row, but the next column, that is total square feet column. So now NaN should get replaced with 1440. So when I run this for bfill, bfill means the next and pad means the previous. So when it is bfill, the next value, that is 1440, has come in place of that null value. Okay, so when access is equal to 0, we'll consider the same column but previous row or next row. But when access is equal to 1, we will consider the same row but the previous column and the next column. Okay, if there is any confusion, you can rewind the video and again watch it. Okay, so this is how we can fill the null values with the previous or next in the column or row. Now it may be a case where we want to replace the null values of particular columns only, like society column and balcony column. We don't want to touch the null values of other columns. That time what you can do is you have to pass a dictionary over here in your fill NA method. And the dictionary key is society. The value is suppose ABCD, means what? In the society column, wherever there is a null value, it should get replaced with the ABCD object or string. Similarly, in the balcony column, if any null value is found, it should get replaced with DEFG. You can also give a value over here like maybe 34. That is also possible. So now when I display, you can see there was a null value here and it is of the society column. So it will get replaced with the value ABCD. In the balcony column, you have null value. Suppose it is there, then it will get replaced with 34. Let us check for price column so it is more visible in this particular display. So in the price column, you have null value over here, which and here also, and here also, and anywhere in the middle also it can be. So these null values will get replaced with the value 34. So as you can see, now it is 34 instead of NaN over here, here, and here. Now, as I said, instead of replacing or filling with some random value or previous and next value, there may be a case where you want to fill it with the mean of that column. So what you want to replace it, you must pass it as the value to the value parameter. You can write value is equal to, select that particular column and apply the mean method. So the mean of that particular column is represented by this, which we are storing in place of the missing value. So let me first of all display the df1 data frame. So you can see that you have missing values in the society column, and here also you can see in the price column and in the balcony column over here. These are few spots which we have detected. So the mean of the balcony column will get replaced in this row 13316. As you can see, the mean. Also, wherever there was a null value in your society column, there also the mean of balcony column has been displayed over here also in your price column. Okay. Similarly, instead of mean, you can find out the maximum value in that particular column and you can display it over there. So in your balcony, the maximum value is 4, which is getting replaced in place of wherever there is null. Now maybe you want to alter only the balcony column. As we have seen here, particular columns we want to change. So let us try that also. So in the society column, I want to fill the null values with df1 of balcony dot mean and price with 34. So what will happen here is the society column, if there is a null value in the society column, it will get replaced with the mean value of the balcony column, and price will get replaced wherever null value with 34. So you can see that in the society column, the mean of the balcony column has come, and balcony column we have not altered. So there, wherever null is there, it will be null only. And price, that is 34, is over here. So in this way, particular columns null values can be replaced with the mean or max of any other column also. Now, if you want to drop the row, if it has even one null value or all null values, that is also possible. So by calling drop any method on the data frame, what it will do is, in a row, if you find a null value, that particular complete row will get dropped. So if I display the data frame, you have null values here. So row with the index 2 and 4 should get dropped. Also, this particular row 13316 and 13317. So let us check. So as you can see, the index itself is making you identify that one which has the row with index 1 has NaN, so it is dropped. Here also NaN, so it is dropped. This particular row also has NaN, so it is dropped. So you can see 1, 2, 4 have been dropped. Then in row number 5 has appeared. 5 means here we definitely know there is 5, 6 up to all these columns, all these rows. So here also 13316 has the null value here. So it has been dropped, as you can see. So if the row has a particular null value in any of the fields or cell, then that whole row will be dropped. Now you may want to have a condition that if any of the fields of the row has a null value, means for example Here also you have null value. In this particular cell also there is a null value for this 13316. So either here or here or both or all, means either all these rows, all these fields can have NaN, all can be missing values, or 2 can be missing values, or 5 can be missing values, or only 1 can also be a missing value. So any number of missing values, if it has, that means at least one, minimum one missing value. You can have one missing value, 2, 3, 4, 5, and so on. But if there are zero missing values, it will not get dropped. Okay, so I'll run this and show you. So wherever there's a null value, at least one, that whole row is going, like 13316. This is the same like drop NA. If you don't pass this how parameter, by default it is equal to any. So if I don't pass also, I was getting the same output. As you can see, 0, 3, 5, 11, 12, 0, 3, 5, 11, 12. So by default, how parameter is equal to any. But if you want to drop a row, only if all the columns or have the null value. Means this whole row, here also it is NaN, here also NaN, all these columns for this particular row, or you can say all the cells for this row number 12, if they are NaN, then only that row will get dropped. So as we can see here, for this particular view, none of the rows have the fields where all the fields are missing values. That means you have either one missing value or two missing values, or maybe 3, 4, but all of these are not missing values. So in this case, you will not get to see any change, because how is equal to all. So here you can see there is only one missing value, so keep this row. Here there are two missing values, keep this row. Only if all these are missing values, drop the row. That is the meaning of all. Okay, by default, how parameter is equal to any. Now, as I showed you also about the replace method. In the replace method, first parameter is the value that has to get replaced. The second parameter is the value which has to come in place of this value. So you can either say to replace equal to the value which you want to replace, and value is equal to the value which has to get replaced in place of this value. So you can say to replace this value equal to this, or simply if you pass np.nan, comma 22, this will also work. So 22 will come in place of all the null values in your data frame. Now either you can write capital N, small a, capital N, like the way it is appearing here, or you can simply write in lowercase also NaN, that is also fine. So now if there are any missing values, like here we knew that there's a missing value, it has been replaced with 222. Here also 222. Now as I said, not necessary it may be a missing value that has to get replaced. Suppose wherever 3 is appearing, or 3.0, that should get replaced with the value updated. So as you can see, here there is 3.0 in this row with index 3. So row with index 3, there updated has appeared. So we are going to replace this value with this value. And the final one more case is interpolate method. What this does is, suppose you have a column which has multiple values. Okay, you have a particular column with the name, some name that column can have, like count maybe. This is a column name which has the values 6, 5, NaN, 6, 7 in its rows. So if NaN is appearing here, we want to replace it with the mean of the nearest values. Means what? 5 and 6 are the immediate neighbors of NaN. Am I right? 5 and 6 are the immediate neighbors in the same column for NaN. So we have to take the mean of 5 and 6. That is 5 plus 6 divided by 2, which is 11 by 2, which is 5.5, which will come in place of NaN. So when you execute this interpolate method on your particular column, then wherever null value is appearing, it will take the mean of its immediate neighbors, that is in this case 5.5, which will replace the null value. So now you'll get the output as, here it you will have 6, then 5, then the mean of immediate neighbors, then 6, and these are not null values, so they will appear as it is 7 and 3. Okay, so this is the original data frame. Now concentrate on these particular values 4.0, NaN 1.0. So now this NaN should get replaced with the mean of 4 and 1. Mean of 4 and 1 means what? 4 plus 1 divided by 2 means 5 divided by 2 means 2.5. So in place of NaN, 2.5 should appear. So when I run this method, you can see that here we had NaN which has got replaced with the mean of immediate neighbors, that is 2.5. So the syntax is the particular column on which you're calling the interpolate method, and linear means what? You are going to go linear means one after the other in the same column. Linear means one after the other, you're going in the same column. Now suppose you want to know the acceptable values for this method, you can simply write Shift tab, you can click on your keyboard. What it will do is it will give you a brief doc string, or it will give you the description of this particular method and its parameters. And if you click on plus, you can see some more things like which are the possible parameters, like method equal to linear, axis is equal to 0, means in the column wise you're finding the mean, column wise you're going to take the mean of the immediate neighbors, or maybe row wise you want to take the mean of the immediate neighbors. So for example, here you have 2.0 and 62. If you say axis is equal to 1, then it will take the mean of 2.0 and 62, and whatever the mean comes, it will get replaced in 3.0 if here we had a null value. If here it was NaN, then take the mean of 2 and 62 and replace the NaN with the mean of 2 and 62. Now just now what we saw was in the column when axis is equal to 1, when axis is equal to 0, that time in the same column you will take the mean of immediate neighbors and replace. When axis is equal to 1, you will take it row wise, the mean. Okay, you can try it out. So these were some techniques by which you can replace the missing values. So a brief summary. We have covered this point number 1. So we have covered point number 1. Then we have worked with a particular data set, point number 2. We have loaded it inside our pandas data frame, point number 3. And we have seen some data pre-processing techniques to handle missing values. That is point number 4. In the further videos, we'll see about the normalization and conversion of categorical variables. So thank you for giving me a patient listening.